Okay, this is the last section in Unit 10. We're on page 81, and this is really just an extension of our work with radicals earlier in this unit, but we are actually going to solve equations now that have radical signs in them. And this is just a little review, real basic, of what we would do to solve each equation. Obviously, the goal is to isolate the variable. And we do that by undoing the operations that are attached to the variable. So in this example, to get the variable alone, we'd subtract 2 from both sides. In the second example, we divide, because the 5 is attached by multiplication, divide by 5, both sides. This one, if x is squared, we're going to undo the square by taking the square root of both sides. And what we're going to do in this unit to get the variable alone, if it is a square root, we are going to square both sides, because we are looking for the variable alone, but not under a square root sign. So when we're solving these equations, he needs to come out of that square root sign. So a couple quick examples right here. The first thing you need to do is make sure that your radical is alone on his side of the equal sign. So he is here, so we're going to square both sides. The square root of a times the square root of a is the square root of a squared, which is just a. So a is equal to 49. The second example, the radical sign is alone. We're going to square both sides. So I'm going to square, whoops, that's a C, square him and square him, and I get C alone is equal to 16. Now at this point, I forgot to say something. When we are working with equations that look like this, the check is really important, because we are going to have times when our answers don't work and we have to throw them out. So in this case, to do the check on this one, we're going to take our 49, we're going to plug it in, and we're going to ask ourselves, does the square root of 49 really equal 7? What's on the other side of the equal sign? Yeah, it does. And in this case, our answer is 49 and we're good to go. But look what happens on this one. We think our answer is 16. The square root of 16 equals -4. There's our negative sign. Well, the square root of 16 is +4. If there's not a negative sign out in front of it, then they don't want the negative answer. So +4 is not equal to -4, and we actually have to throw this answer out. And there is no solution for this equation. So the checking is really important. Here's some vocab we can fill in right here. These solutions that do not work have a special name. They're called extraneous. Extraneous solutions can be created when squaring both sides. And extraneous solutions, we know if it's extraneous by doing the check. It will not check correctly. It'll solve okay, but the check is where you know whether your solution is extraneous or not. So it's a good idea to check your solutions. It's more than a good idea. You really need to do it. But especially important, so it's a good idea to check your solutions anytime you're solving an equation, but it's especially important when solving square root equations. So to solve an equation with a radical, we're going to isolate the radical first. If he's got anything else attached to him, we're going to move him to the other side, and then we're going to square both sides of the equations. So let's run through a couple quick examples before, well, just one on this page, and then we'll pick it up with the next video. So the radical sign is alone. That's good. So now I am just going to square both sides. Whatever's inside this radical sign, when you square it, he just comes out, just like he is. Looks just like that. Now I'm solving for x, so I'm going to add 1 to both sides. I'm going to get 5x is equal to 10. I'm going to divide both sides, and I'm going to get x is equal to 2, I think. But now I'm going to go back and check and make sure this really works when I plug it in to the equation, the original equation. So 5 times 2 minus 1, when you clean all that up, does that really equal 3? Well, 10 minus 1, that's 9. And yes, the positive square root of 9 is 3. So this answer checks, and we're good to go. We'll pick up some more examples in the next video. Thanks for watching.